All right, this is APAB Calculus. We are doing the midterm review packet, and this is our calculator active free response, number 19. So the function g is defined for x greater than 0, with g of 1 being a 2, and g prime of x being this ugly expression, and g double prime, thankfully they did the derivative for us, being right there. Okay. Find all values of x on the interval from 0.12 to 1, for which the graph has a horizontal tangent line. So here's the deal. We want to translate this, and even though it's a calculator, like the calculator is going to do some of the work for us. Sorry, we're beach balling. The calculator is going to do some of the work for us, but we want to translate what this means. So the ask, right, and by doing this, we're going to be demonstrating enough work to get credit, right? The ask is that G has a horizontal tangent line, okay? And so we need to translate that into what that means, right? Well, the definition of having a horizontal tangent line is that G prime of x is going to be 0. And that is something I can make my calculator do. Because if I use my calculator to put g prime in, right, so I'm going to put my y1 in as sine of 1 plus 1 over x. And this is a great time to double check that you have your calculator in radian mode. Because if there are trig functions, like anytime you're on the calc test, but especially as soon as a trig function pops up, you better be in radian mode. But there's never a time on a calc test that you'll be using degree. You do use it for AP Physics, though, so be cautious that you do switch back and forth. So I'm going to go here. I'm going to type in sine of, oh, and my bad, I wrote 1 and it's an x, my bad. So sine of x plus 1 divided by, oh, not division, divided by x, right? And so I double check that that's what my g prime is, right? But this is my g prime, and I want to do second calc 0. Now, I am going to set my window to only from x is 0.12 to x is 1, right? So I'm going to adjust my window, right? Because there might be a ton of these because it's a sine function. So I go to my window. I'm going to intentionally do 0.12. I'm going to go to 1. Because it's a sine function, it's never going to get higher or lower. It's never going to get higher or lower than a 1 because, like, it's the output of this function. You're putting whatever this nonsense is, you're putting it inside a sine. So really, there's no reason to have something go as high as 10. I would suggest that you, just for your sanity, make it a slightly better window. And go ahead and graph this. And this is the graph I'm looking at, right? So basically, I want these two spots. So I'm going to do a quick screenshot, right? This is what I'm looking at. I want this thing and this thing, right? So I'm going to go ahead and do second calc, and I want 0. I'm going to have to do it twice, right? I always work from left to right. You don't have to do that. That's just my preference. There's no real logical reason for that. So I go all the way over to the first of the zeros. I'm to the left of it. Then I go to the right, and then I hit enter. So the first 0 I get, right? So I'm going to get x is approximately 0.163, right? And then I'm going to do it again. And actually, I'm going to just screenshot that guy so we have it. Oh, if anybody is mildly taken aback by this value that you see for the y, I just want to throw this out there in case that's flipping you out. This is actually 0, right? Because what this means, right? This means a -2, right? With the decimal moved 1, 2, 3, 4, 5, 6, 7, 8. I ran out of room. 9, 10, 11, 12, 13. That's how many zeros there are. Like, it's ridiculous. I'm not even counting them, right? Like, it's ridiculous. Okay, so this is 0, right? When you see this, like, e -13, don't worry, that is y equals 0, so if that's flipping you out, don't panic. If I do the other one, right? So if I do second calc 0, I'm going to scroll over. I want to just be a little bit to the left of this first 0, so I'm to the, or of this second 0, so I'm to the left, cross it. And again, I have no good reason why I work from left to right on my zeros. I just always have. So I'm going to get that the other one is 0.359. These are my two answers, and that's it, right? You get no credit for calculator syntax, right? But the work that you're going to want to include to justify your answer, right? You want to make sure you're clear that you know that this is what you're asked, this is what it means, and then you're using your calculator to do it, okay? You still have to do the thinking. Your calculator doesn't do the thinking, it just does the number crunching for you, all right? All right, let's move on to the next one. So this is part B. Same function, same everything. So on what subintervals, same window from 0.12 to 1, if any, is the graph concave down? So again, your job here is to translate what's being asked, right? So you're asked, sorry, my mic is getting bumped, I apologize. You're asked when G is concave down, right? So that's the ask. And again, we're on that specific interval, but we can talk about that in a sec. So what's the definition of being concave down? Well, by definition, not in this problem, just in any problem, it's that g double prime of x is less than 0. Well, here's the fun thing. There are two ways to do this. I can either, so I have two options. I already have g prime in, right? So there are two ways to do this. Option one is to put, let's say, y1 as my g double prime, like this whole mess, which is fine, and then look where it's below the axis. And that's fine. Because if it's my y value, I can look for where that y value is below the axis. But option 2 is kind of cool because I already have y1 in my calculator. G double prime is the slope of g prime. Meaning, if I want g double prime to be negative, then I want g prime to be decreasing. Well, I can see that literally on this graph. So if I screenshot this real quick, so again, I'm going to show you both options. You should not do both options on an AP. You should do whichever one occurs to your brain first. But if I pick option 2, right? If I pick option 2, which is this option where I already have this in my calculator, I'm looking for where g prime is decreasing. Well, that's here and pretty much only there, right? So basically what I could do is I could find the coordinates of the max, second calc max. I could find the coordinates of the min, second calc min. And g double prime is negative between them, right? That's when the slope would be negative from whatever this max point is. Now, if there's no max here, then it would just be, so it's either the max or honestly, it's the 0.12. I don't know if it's the end. I'm not going to know that until I second calc max. But that's one option, and I'm going to show you that you get the same answer if you do it both ways. So we're going to start with this one. So if I do second calc, I'm going to go ahead and do min first, only because I'm closer to the min. So I'm just going to, usually I work left to right, but we'll go ahead and find this one. So I see that it has bottomed out and is going back up. So I'm to the left of the min, I go past the bottom, I'm at the right, I hit enter. So I have this minimum value, right? So we're going to drag that over. Okay, so there's my min, right? And if I want a second calc max, there might be a max, right? It's hard to know right now if there's a max here. So I'm going to go up, right? Now notice if I go, so see the y values are increasing, right? So see the y values are increasing here, right? But then it goes back down. So there definitely is, there is a max there. So I'm to the, and I'm still in the 1.2 or the 0.12 bound. So I'm to the left, I go up and over to the right and I hit enter, and sure enough there's a max here as well, right? There is a max and the max falls in the window that I was given, so that's legit, right? So if we then, and I'm just going to switch the order of these guys real quick so that they make logical sense from left to right. So this function, right, this graph that I have, which is g prime, is decreasing between this max and this min, meaning that my answer, right, my answer is that g is concave down on the interval from 0.129 to 0.22, either 2 or 3, depending on if you round or truncate, right? So that's my concave down window. Now that's one way to do it, and that's great, and that's probably how I would do it because it's faster to not have to enter the other function in, right? And I guess I'll put this in as y2, and then I would turn off the y1. I wouldn't delete it because you might end up needing it again, right? So like it's not smart to delete it. It's smart to just go over and turn it off. So I can put in my y2, my g double prime. But again, the caveat to doing that, the thing to watch out if you do this, right, if you put in your g double prime, is that this is a really ugly function and it's easy to make a mistake. So just kind of had that on your radar that this is not the easiest thing on the planet to enter in your calculator, right? So there's the first thing. Then I have a cosine of an x plus a 1 over x, right? And that's that. Okay, now if I do it this way, and I have graph on the same interval, now if I do it this way, where this graph is g prime, I'm looking for where this thing is negative, right? Well, here I might want this window to go farther down. So here I might want this window to go like -10 and see what happens. I don't know. Let's just see how that looks. Okay, so you see what I'm looking for here because this is the G double prime graph. So again, this is a different way of doing it. Well, now I'm looking for this window right here, where it's like down here. So I'm looking for these two zeros. So here, and actually let me switch colors for that for a sec. So here, I'm looking for from here to here. So I want this 0 to this 0, because I want when this graph is physically below G double prime is the y value and it's less than 0. So I promise that if I second calc 0, I'm going to find the same two values. It's just, I think the other option was slightly easier. So I'm going to scroll over and I notice that these x's are getting smaller, right? They're getting smaller. All right, I know I'm getting close to the 0.12. I'm hoping I see the cursor soon. Okay, there it is. So there's the cursor. I keep going. So now I'm up above the axis. I can see that because the y is positive. So I hit enter. I go back to the left. I hit enter. And then I guess. And sure enough, I get the same exact 0 that I got a second ago, right? And I'm going to go ahead and drag that on, and I'll show you in a sec that I do get the same one, right? And then if I do second calc 0 again, this time I'm going to scroll over to try and get to the other one, and I see that there's to the left, right? I see that the y's are increasing. I cross the axis, hit enter, and there's my other one. And what you're going to find when I look at these two numbers in a sec, when I drag them down, is they are exactly the same. It's a different method for getting the same answer. I don't care which one you pick, right? But yet again, right? So if we look here, my answer is between 0.129 and 0.222 or 3, depending on if you round or truncate. And again, that is when my G double prime is negative, so G is concave down. So the trick is that you really can't do the answer without a calculator, but you have to put in the time to figure out what you're looking for and then figure out how to find it with the function that you were